Well, greetings, Mr. Kolazar's class. Today we're going to look into section 9.4, types of chemical reactions. And as we look into those types of chemical reactions, there are going to be 5 that we're going to need to know about: synthesis, decomposition, single replacement, double replacement, and combustion. Now, one of the things to do before we get started looking at those 5 is we're going to be looking at the idea of E for element and C for compound. And as we look at those ideas, an element, remember, could be like sodium, or copper, or diatomics like hydrogen or oxygen, whereas a compound is going to be when 2 or more elements are chemically combined, like sodium chloride, or water, or copper 2 nitrate from our lab. So now as we start to look at these, to break them down into each of our 5 types of chemical reactions. Our first one, synthesis. Synthesis is going to be a reaction between a metal and a nonmetal to produce a compound. So we're going to start out, general equation. You could look at it as like an element plus an element is going to produce a compound. Or we could look at it like A plus B produces, oh, what happened to our B? Produces A, B. So the 2 are chemically combined together or put together. So our first type of reaction, synthesis, sometimes known as a combination reaction, combining of 2 elements. Decomposition, our second type of reaction, is going to be where we start with a compound, a bigger piece, and break it down into 2 elements. Now as we break it down to those 2 elements, the metal and non-metal is generally what we're going to form, or you could also look at it as being smaller compounds. It may not necessarily be 2 elements, but it'll be smaller portions or parts to that. So our general equation, compound, is going to break down to an element plus an element. Or you might even see it written as a general equation, AB, like the synthesis reaction ended with, is going to produce 2 smaller parts, A and B. So synthesis and decomposition are just opposite of each other, putting together and breaking apart. Now our next reaction, single replacement. A single replacement reaction is one where we have an element and a compound combining to form an element and a compound, but they're going to be this time new elements and compounds. So general form, we could look at like if we had that AB plus C, and C is going to come in and kick out B. So now we have a C as a compound plus B as an element. And a couple key hints to remind: metals replace metals, nonmetals replace nonmetals in the reaction. So if C was a metal, it would replace A, the metal. If C was a nonmetal, it would be replacing B, the nonmetal. So we're going to have element compound producing a new element and a new compound there. From single, double replacement, we'll have 2 replacements happening here. Compound plus a compound is going to produce a new compound and a new compound. So for this one, we're going to kind of write out full scale. So I'm going to go with A as a positive, B negative, plus C positive, and D negative. Now, positive and negatives are going to combine with each other. So the positive A and the negative D are going to combine. A positive, D negative, and remember positive always written first, so the C and B are going to combine. So C positive and B negative. Parts are compounds. Parts have switched places with compounds the A and the D have went together, and the C and the B have switched places and combined together. Remember the positive and negatives? Positive is always going to be written first. That's why we had the C and the B negative part there. So double replacement, two replacements happening. And our fifth type of reaction, combustion. Anytime you think of combustion, you can kind of think of our fire. Might be a good example. Combustion, we have a hydrocarbon. Remember, all hydrocarbons are going to have hydrogen and carbon in them. So I just have a generic formula, X and Y, carbon and hydrogen, plus oxygen. You always need oxygen in your fire, is always going to produce carbon dioxide and water. So when we look at this, CXHY is going to be any hydrocarbon. Generally, we have 2N plus 2. So if you had like C5 pentane, of H12, 2N plus 2 to get that. Afterwards, if you have CO2, it's going to be a complete combustion reaction. It's going to be incomplete if your product is actually carbon monoxide instead of carbon dioxide. So our description about this is any hydrocarbon, carbon plus hydrogen, you need oxygen always in order for fire or for burning, and then you're always going to produce CO2 and H2O. So it's different than any other types of reactions we've had. So from here, using these 5 types of reactions, we're going to use it to be able to identify any of our types of reactions, whether they be combustion, double replacement, 2 switches happening, single replacement, 1 element replacing another element in a compound, decomposition, breaking down of our compound into elements, or synthesis, creating a new compound from 2 existing elements. So at this point, our chart should be completed with those 5 different types of chemical reactions.